Okay, so I got this one answer, or A. So basically, yeah, a node is like objects that is connected by edges in a graph. Like, and the edge, usually like the edge you don't represent it by like code, but it's true like the relationships by like either aggregation or something else. In linked list like cases, right? It's connected because like one node knows like who its next is, and for like trees, each node is probably going to have like a set of all of its like neighbors and stuff like that. And I received another comment. Um, for A, yeah, can be nodes can be generic, yeah. And the instance variables you need in a, oh, I should clarify, not just in it. For linked lists specifically. So thank you again for answering. Yeah, you'll need data. You'll need to know what your data is and your next. And to clarify, you need to know, well, the data depends, right? Like whether or not you declare it as, what do you call it, generic. If it's generic T, then it's a T data, and then like node generic T next. But that depends on like how you're gonna plan to implement your node, yeah. Okay, thanks for the answers. So how would CMD? I got several answers. So generics let you easily change what type of class is used within a class without casting. Yeah, this is true, right? Later when we create a generic node class, we can see how this is possible. Because you can just like simply change like the type. Yeah, because we declare it's like a generic like a T variable. So that means like when we reuse the class, we can declare the node as like node of string, node of integer, and other like types. So yeah, it brings flexibility by its capability to bring like different types. I will also like to add on that. So once you declare, then that means like you can't put in any other object like types besides string. So it's like a good like check as well. Okay, thanks for sharing your thoughts on C. So I would like to hear like B. Let's try it then. How do you create a generic node class? And we know that it needs to have a data and an X. And also keyword here is that I want it to be generic. Yeah. So we're right now we're doing number D. If you any of you guys are like confused on what's going on, or if you just like came in, we're doing number D right now. Creating a generic node class. The keyword over here is that I want it to be generic, and we already know from B that it needs a data and next. think about what is exactly data is and what exactly next is. So to clarify, next means your next node, while your data is like, yeah, like the data within. So yeah. I'll give you guys like 2 more minutes to think about the.
I think you're muted.
Yeah, thanks. Um, so yeah, again, this is for the answer for D. This is basically perfect because as you can see over here, like, look, it's like generic, right? Because of the variable type, it's just like a placeholder, like name, for example, this like T. And then so the data type will be whatever like the placeholder name is, right? T of data, and your next will be a node as well because next means like your next node. So that means like if we were to use, so if we were to create this node class in a separate like class, for example, like, so for example, node of string like this. So internally it becomes like, and then string data node string next. So from here you can kind of see that like why generics is useful, because like anything that's not string, it'll not be able to become the data, it'll not be able to become like the next node, basically. So that's why generics is like pretty like important and pretty like useful, because you can reuse this class like over and over again for like different data types. Okay, cool then. Okay, so I received some comments saying array 1 and array 2 will go to the stack, and then what goes to the heap. Oh, I see. It's because like you think this is like what do you call it? String literal, huh? That's why you thought that it's like going to the heap. Yeah. Okay. Yeah, I think I see like why this example is not really that good then, because like you guys probably think that because of string literal, huh? What I'm okay, actually for now, just ignore this like hello and also the world. I'm just like more concerned about like this basically. Just don't think about this one for now. Don't think about like a string of literals. Just think about like what will happen if you declare something as like new. So it's probably like in a heap when you like start thinking about like string literals, but that's like too complicated. So just like for now, just like ignore the array1 dot add hello and array2 dot add world for now, because yeah. So just right now, yeah, I want you guys to like consider how like if you declare something as new, it'll create like a new memory location and it'll like go to the heap, right? And then where will array 1 point to and where will array 2 point to? Yeah, both pointing to this one, right? Because array 2 is pointing towards this one as well because this is just like a reference, right? So since it's equal to array 1, it's going to point to here as well. Okay, so now, most importantly, I want you guys to think. For a reference, if you do anything to a reference, right? Consider that it's like pointing to the same like object like this. If you do anything to a reference, is it going to be reflected to this array 1 as well?
No.
Oh yeah, just like for this as a session, yeah, like don't turn on your mic. So just like but I'll like to know though, like why don't you think so? Just like in the chat. Feel free to privately message me. So again, the question is, if I do anything to array 2, will it be reflected on like array 1? Okay, so I got an answer saying that because you're doing it to array 2. Okay, so let's and while I got another opinion that's saying that it should change array 1 since both points to the same array list. Okay, so we'll just like quickly like open Eclipse then. So let me just share again. Okay. So this is basically the same code over here, right? Array list string array 1 creating a new array list, and then your array 2 here is pointing towards like array 1. With array 1 adding a hello, and then array 2 adding world. So let me open the chat again. Okay, also got another clarifying question. The string literal hello and world are not heap because I commented out. Like just forget that existed. Forget like I wasn't like asking for it. Like hold on. Yeah, like for now, for this like stack heap diagram, just like think that I commented out like array 1 out add hello, array 2 to add world, because otherwise like yeah, you'll probably like include them. But that's like making the example like too complicated, so that's why I like commented out for now. But now we're back to this one, so yeah. Okay, so we have like two hypotheses, right? So first, if array 2 doesn't affect array 1, array 2 is just going to print world, array 1's just going to print hello, right? If they're like two completely like different like objects, right? But if array 2 affects array 1, both of them are going to print hello world. Right? So we'll see, because think about in consideration that like array 2 and array 1 points to the same array list object. Okay, so we'll try to run it and see how it go. So you can see from array 2, system out print this, the contents of array 2, you have hello world, and array 1 over here, you also have hello world. Okay, so basically the point that I want to make over here is that, so let me share my screen again. So basically the point I want to make here is that if you have like simply a reference and not a new object, whatever you do to the reference will be like array2 will be reflected on the other like references that points to the same object, like array1. That's the point I want to make, because this will be like pretty useful. Like this kind of like concept will be pretty useful when we're like traversing and also adding and removing stuff from the linked list. Okay. Any questions? Anything that's like unclear? So again, it's like because array1 and array2 is pointing to the same array list object, that whatever you change to this like new array list is going to be both reflected on array1 and array2. It's a different case if you were to say array2 equals to new array list. That'll be different, because that means array2 will be pointing to its own like array list object, and they won't like interfere with each other. Okay, any questions? So I got one question says, to clarify, array list and array list 1 and array list 2 point to the same array list. So yeah, they're both like reference to the same like array list object, yeah. And then I got another question that says, will it change if we pass in array1 into the constructor? Which constructor are you talking about? Oh, so are you saying that if we kind of like switch it around, that I created array2 first and then like pass in array2 like this? So basically like switch the naming around? Is that your question? Oh, okay. So you're saying if we were to do new array list, okay. So let's try it out then. What if we were to do, one sec, let me check comment again. My first guess is, okay, so yeah, if you see in the chat, someone says, okay, what if we do array2 equals to a new array list, and then you pass in array1 into the constructor, right? My guess is that, yeah, like it'll create a new location precisely because you said new keyword array list, which will create a different array list, but then what do you call it? But then it has like the contents of like array1 to fill it in with first. But let's like double check then. So let's double check. Basically, earlier what he said is that so this is basically what he proposes. So he thought that, okay, like, and then I say that, well, it's because we're creating a new array list, so it's going to create a completely new object. So by passing an array, and you're gonna get a world, but I think it wouldn't like do anything to array1. So let's try it out then. So let me recompile and I will run it. Yeah, as you can see, array2 only prints hello world, while array1 only prints hello. Therefore, they're completely like two different objects, because array1 is not affected by the changes in array2. So the keyword over here, the like key concept over here, is that if it's like two references pointing to the same object, whatever change you make to one reference will be affected to the other reference. But if you were to create like a new object like the one we did earlier, like new array list like that, array2 is going to point to a completely different object, and they won't like interfere with each other. That's like the main idea over here, and it'll be like pretty useful when we learn how to kind of like iterate and also like manipulate like linked lists. Okay, I got this. It says, okay, yeah, assuming that it's a generic linked list, yeah. So again, we're not creating a node, we're creating a linked list. So yeah, a linked list, it needs to know what its head is and what its tail is. So the two properties of head and tail. So head, so head is your like first ever node. It should not have anything point to it, so nothing point towards it. So let me just write this down. And then with tail, oh, but your head can like points toward one node only, and then your tail must point towards like tails next must point towards null. So as in like tail dot next must be null. Okay, so these are the two properties of like head and also your tail. This is what a linked list must have. And in addition to that, one node must only have like one next and only one node pointing towards it. Like temporarily, you can set two nodes to be like temporarily, okay? Temporarily, you can potentially kind of like set two nodes to have like you can have like a node that have like two nodes pointing towards it, but you need to like fix it obviously for it to be a valid linked list. Okay. So we'll just like start in a new method, iterate linked list that iterates through each node in a linked list and prints the contents of its data. Okay. So first, like just like give me suggestions first. How do we iterate through this one? So let me draw a diagram over here. You need to remember that each node knows like what its next is, right? Each node contains T data and also node T next. So that means like each node has a knowledge of first like what its data is, but most importantly, what its like next node is, okay? So I'll just say this is node 1. 2. So just like as I'm like drawing this, like start thinking of like a pseudocode then. Okay. So T data will be 1, right? Like assuming this is like a node of like integers, your integer data will be 1, and then your next node will be this 2 over here. And the next node for this one will be 3, and then this one's next will be 4, and 4's next will be null, right? Based on the properties of like linked list, that your tail must be pointing towards null. So, and then let's think about the concept that we talked about earlier then. With references, you can gain access, right, to whatever your like next node is with references. And then with a linked list, you know exactly what the head node is. So how do we take advantage of the fact that if you were to create references, you will gain access of like what your next is, and then you also know where to start. Yeah, feel free to kind of like tell your suggestions in the comments. I'll wait for like 2 minutes then. Okay, I got one suggestion that says, okay, do this. Note, oh, my bad. Once you click, once, oh, actually, never mind. It's fine. Once we declare our linked list to be T, then I'm pretty sure if we declare our node as like T, it should be all good. So anyways, that's besides the point. So I got this like one references, like one way for you to act stack heap diagram. So imagine this is your stack, and then down here is your heap. So node 1, right? Because in a method, we'll be creating like multiple nodes. So let's say I have node 1, node 2, node 3. Heap, I'll do like equals to new node equals to new node. And then when I declare it as like the T data, it's like 1, and then the next node has like node 2 in the like main method when I create this. And then right, and I'm going to have a new node for this one too. And I'm going to have a new node for this one too. And I'm going to have a new node for this one. Right? And then the stack heap diagram, draw it like this, draw it like this. So over here and over here. Basically, if you were to make a copy of this one, right, you'll create kind of like a pointer in a sense. You're gonna create a pointer. Let me just name it as like over here, I'll create something called like a copy. Copy or like pointer. Okay. So first, if we were to say copy equals to head, where is copy going to point to in the heap diagram? Again, the question is, where is it going to point to the heap? Node 1. Yeah. Right? It's pointing towards this one. And then if you were to say, and then, okay, cool. So that's how you got the access. How would you, so now copy knows what T data is and what node T dot next is, right? Sorry, like what the next value is, right? Since copy is pointing towards this one, it knows what the data of this node is and also what the next node is, right? So how would you access this next node then? How do you like progress like copy to go to the new one? copy equals to copy.next, right? Because copy.next is this one, right? Copy.next is this one. So that means that if you do, and then the next is equals to 2, right? Right? So let me just like erase, like try my best to make it like less confusing. So if you were to do copy equals to copy.next, which is 2, so now you're setting copy as node number 2. So now it's going to point towards this one, right? And then copy.next, the next is like 3 over here. So and then copy, since copy.next is 3, now copy will point towards node 3 and it's going to point over here, and then the same thing with number 4. Okay, so to sum it up real quickly then, how do we iterate, like encode? So you have so like an iterate method like this, right? So how would you start this up with? So first you make like node t copy equals to head, and then how do you stop? Consider something that's like always true, right? We want to continue on until a certain condition is met. Until we can't iterate anymore. So how should we do this? How should we iterate? Because we want to do this copy equals to copy.next like over and over again, right? Okay, I got the answer. While copy is not equals to null, right? Because once it for like number 4 over here, the next is null. Right? If you do and a null is over here, and then copy, if copy is null, that means you don't have any more like nodes to look at, right? And then on your own later on, like I want you to consider why it's not copy not equals to like tails or something like that. So just consider that, but for now, in the interest of time, so yeah, it'll be copy equals to copy dot next. Yeah. And that should iterate through the. Okay, so any questions? Okay, so hopefully that was like pretty clear. Anything you guys are confused about? Okay, so again, to reiterate, we're able to do this because of the fact that copy is a reference, and the reference has access to the T data, and also most importantly, what the next node is. So we simply take advantage of that by setting like whatever our like current next is as ourselves. So we like change our reference. Now it's pointing towards the next like thing in the heap, and then the next one, and then the next one. Okay, cool. Okay, if I were to say, right, look at this node, red dot node's like next is the blue node, and blue node is pointing towards null. If I were to change where red is pointing to, so it's now pointing towards green, and then I remove the access to red. Sorry, I removed this one. As far as the linked list is concerned, can you access blue? No, right? Because we don't have any more, like, we have no other way to access like blue anymore. Okay, so keep this in mind. This like concept of like setting your next node like this might cause something like this, where you accidentally kind of like remove like one node from the equation. So this is pretty important when we're so yeah, it's not accessible. So this is pretty important when we create an add node. So yeah, our essay session yesterday didn't cover this, so let's try this one together then. Okay, so the diagram that we're thinking about is like this. Wait, too small. Okay, say I want to insert this red node, so it's between this. So it's between this, okay? And then consider as well that it's pointing towards here, and this is pointing towards this one, okay? So think about it. Let's just say, okay, wait, I'll remove this one for like clarity's sake first to make this like super like simple. So just ignore this like lines over here, and this one's pointing towards null. Okay, consider, this is your head over here, and this is your tail over here, okay? How do I like properly like insert this like red circle over here? Think about it. Feel free to give me your suggestions. So this is your head, and it is your tail, right? And you can simply say like head.next or like tail.next or something like that. And you have like access to this like red node, right? So this red node has like t data and also like t next, right? But your next right now is still like nothing, like it's still like null. But we want the next to be our tail, right? Well, this is your head node. You have like a t data, and then right now it's not t next, it's node t next is equals to tail. Right? And then this is your tail node. And you have your t data, and your node t next is pointing towards null, right? So think about this one. How should we change the next in such a way that we don't accidentally like delete nodes like this? What will happen if I set head node dot next equals the red node? What will happen? So again, my question is, if I were to set head node dot next like equals the red node, what will happen to tail node? The pointer for tail will be gone, right? And then as far as the linked list is concerned, your tail doesn't exist anymore if you were to do this, right? We don't want that. We want to preserve this tail node. So that's not the best implementation. And again, the hint is that temporarily you can make like two nodes point towards like the same node. So basically, temporarily, tail node can have two things connected towards it, but you have to fix it for it to be a valid linked list. We should make a copy of head.next before changing head.next pointer. That's too complicated, I think. I mean, you could kind of like make like a whole ass like new node to like save state, but that's like too complicated. Okay, so I got this one answer that says, okay, next will be red node. Red node's next. Sorry. So first, make red node dot next equals to tail node. Yeah. So what we want to do over here is first we make this one point towards this one, right? So temporarily, this tail node will have 2 points pointing towards it, but then we change head nodes next to this one, just like this 2 steps, and then you're done. This is like valid. Okay, so with the remaining 6 minutes, then let's code this together then. So public void add node. Doesn't matter what order it is done. It matters. It matters, right? Because if you were to do this one first, right? If you were to do this one first, if you were to set heads like next equals to this add node, but you haven't set red nodes like next to be this one, you won't get access to this tail node anymore, right? Like this example. You don't have access to this anymore. Like you don't know like what the location of blue is. Because as far as the linked list is concerned, this is it, and you don't have access to this one anymore. That's why we have to first you have to like no, I don't have this one. So first you have to do this one and then do this one. Now the linked list will like include everyone. So first do this one before you do this one. Okay, so with 5 minutes left, I think we could do this. Okay. I'll make it easy here. So instead of just string, I'll do like node string. So okay, let's think about this logic like step by step. First, we want to find first, right? What is like our target node like? Sorry. Where should we like put this? Sorry, I mean like where should we like put this like add me after this? So what should we do first then? Like this is a pretty small example, but like imagine if you have like multiple like circles like this. And then your target, and then after this, for example, is this one. This is after this. And then you're starting from the head, right? And this is your tail. So first we need to like reach into like this point first. So you can start it the same way as like you do your iteration earlier. But most importantly, just like any other one, you need to have a pointer, right? Pointer that goes here, and then goes here, and then goes here, right? So just like the iteration earlier, first you need to create your pointer. Right? That equals to the head. After this is the node that like you want to insert add me after this, right? And don't just like think about just like with this one. Like, okay, what if I made it like this? Right? Don't think about it think about it more general. Don't like say like the dot next is like immediately tail or something like that. Just think about it in like a more like general case. So for example, like what if like after this After this is over here. And then you have your node pointer over here, right? So that means like in this context of this example, head node will be your after this. But since we're out of time, the key part, okay, I'll just write the key part over here first. So find after this node. So this is like a pseudocode, okay? Like while pointer not equals to null, find after this node. And then so first, right? This is your first step. This one. And then the here over here is your second step, right? So first, add me, right? And set add me to, and like right now your what do you call it? Like after this has access to this one, right? But then you want to like make this one. Sorry, you want to make add me dot next to be after is this is like next, okay? And finally set after this is like next to add me. Okay. And then else, like else, keep on iterating. Okay, cool. It's already 1 p.m. So I'll just stop sharing now. Oh, oops. Okay, thank you everyone for like coming. So yeah, that's all for today's SS session.